All right, so so we're gonna be. I'm gonna be extra careful. We had a little bit of a frustrating time last time with some.
Hey, so we can't see that screen there that's behind you in Randolph.
You can't see. You don't have my shared screen. So so I'm sharing it right now. If you don't have it, I could tell that only one of your monitors is being used for Zoom right now because I could see a corner of one of them. Like the two monitors that face the instructor, not the projectors, like I could see nothing's on one of them except for the Zoom window, so I don't know if there's a setting. Sometimes it hides behind the other one, is what I'm hearing up here, so.
You have to double click it, it'll get out of full screen for you.
Like the shared screen should be on, if you're, I guess it's Ben who's up there, if you're at the computer, the monitor that's to your left should be the one that has the shared screen. I can text Asher. Let me see if I can get him to come down.
Somebody equations fill out how you get in the whole whiteboard just kind of.
Yeah, he just showed up one day to start writing the list.
Yeah.
Any questions, right?
Me and Matt were just taking pictures.
Hey Asher, I've got students in Clark 110, and I'm sharing my screen, but they don't seem to have it. And I don't know if you're in a position to run down or send somebody else down to help.
Yeah, went over mechanical and fluid kind of stuff. Oh, on his exam?
Oh, okay, great. Ash, thank you, Asher. Bye. All right. Perfect. Okay, so now, yeah, we had a little bit of a frustrating time last time because there were some couple algebra mistakes that bit us right in the behind. Now I can't. Oh, okay, hold on. Let me do this. Give me a second. Okay. And so that made these problems last a little bit longer than they already are, and then they do take a little bit of doing. So we're gonna do a couple more examples today. Hold on one second. I'm gonna. Okay, great. So let's do a couple more examples. How do we start? How do we begin solving a non-homogeneous equation?
Particular form?
Say that again?
Find the particular form?
We will find the particular form, yep, but that's usually not the first thing we do.
The characteristic equation.
Yeah, we need the characteristic equation because we're going to find the homogeneous solution first. So what is the characteristic equation?
I want to say r squared, no. Yeah, r squared plus 4r plus 4.
Great. So there's the characteristic equation. And this is, of course, I should set out, we're finding the homogeneous solution first. And this factors. In fact, I think it's a perfect square, which means we have just one repeated root. So what does that mean for, like, what is our homogeneous solution?
C1 e to the negative 2t.
Close. When we have if it were just one root or distinct roots, we'd have the constant times e to that power. But this is a repeated root, so it's c1 plus c2t times e to the negative 2t. Not just a constant times the exponential, but it's the linear times the exponential. And this is why, right now, this is why we always find the homogeneous solution first. Because when we look at the finding the particular, right? We look at the forcing function and take our cue from that. So normally, just looking at the forcing function, what would we say is the form of our particular? A e to the what?
BT.
To the what?
BT.
Right, but what is it in this situation, for this problem?
Negative 2t.
Okay, so normally that's what the guidelines say. But there's this tricky bend here. If xp is a solution of the associated homogeneous equation, then we have to use t to the k times xp, where k is the smallest positive integer such that t to the k xp is not a homogeneous solution. So here's what that means. Our homogeneous solution was this linear times e to the negative 2t. Because the powers on e to the negative 2t are the same, like this, constant times e to the negative 2t is already a part of the homogeneous solution. And so is t times e to the negative 2t is already a part of the homogeneous solution. So what we need to do is add a factor of t squared. So this is why we always find the homogeneous solution first, so we can make sure we get the proper form, start with the proper form for the particular. So a t squared e to the negative 2t. It's really important to note that in order to force us to need that factor, it was e to the negative 2t. Like it wasn't special that it was just any exponential. It's that it was this exponential that was already the homogeneous solution. So if the forcing function were 2e to the negative 3t, we wouldn't have to worry about it at all. All right, it's that they were the same function. So so here's our particular. And now, what comes next? we need to find A, right? Like that's our next goal. So how do we do that?
We can plug in the initial values.
Well, the initial values are usually what we use to help us find those constants, which we'll do at the end once we have the total solution.
Maybe take the derivative.
Yeah, maybe the derivative and the second derivative. Right? If the particular is a solution, then when I find x prime, xp prime, and xp double prime, and substitute the functions into the equation, it should hold, right? It should be equal. That's what will help us find the value of A here. So we have to use the product rule. Which I think gives us that. I'm going to simplify, and I'm going to take out an A and e to the negative 2t. Oh, and a 2, I think. So we have minus t squared plus t. And use the product rule again to get the second derivative. So 2a e to the negative 2t times minus 2t plus 1 plus negative 4a e to the negative 2t is negative t squared plus t. I'm going to take out a 2a e to the negative 2t again. And minus 2t plus 1 minus 2a times negative t squared plus t. Oh, not 2a, just 2. I took the a out. So if we distribute the negative 2, this becomes positive 2t squared minus 2t. So that stuff will simplify. It's 2t squared minus 4t plus 1. All right, so we did this so we could make the substitutions and plug them into the equation. There's some more space on the next page. I think I'm going to start that process here. So x double prime is 2a e to the negative 2t times 2t squared minus 4t plus 1. And then 4 times x prime was 2a e to the negative 2t times t minus t squared plus 4 times at squared e to the negative 2t. And I think I'll just factor out the 2a e to the negative 2t again. So we get 2t squared minus 4t plus 1, and then plus 4 times t minus t squared plus 2t squared. Okay, so this is 4t minus 4t squared. Let's see what we got in the brackets. We have 2t squared plus 2t squared minus 4t squared, so those all cancel. We have a negative 4t plus 4t, so those cancel. And I think that just leaves us with 1. What's A equal?
Equals 1.
Yeah. A equals 1, and that means that our x particular is t squared e to the negative 2t. Put a pin in this. We had already found, I'm going to scroll right back down to this in a second. Just reminding us, we'd already found the homogeneous solution. Now we have the particular solution as well. What's next?
Now we're going to find C1 and C2.
Yeah, and leading into that, how we begin that process is we get the total solution or the complete solution. So x of t, the function we're looking for, is the homogeneous solution plus the particular solution. We add those together. And I'm going to simplify this first just by factoring out the e to the negative 2t. So we have c1 plus c2t plus t squared e to the negative 2t. And yeah, we want to find c1 and c2. How do we do that? What do we use? Yeah, they gave us, and I'll just remind us all to make sure we have our mics on so we can include folks in Randolph. Yeah, we're gonna use the initial values. They told us x of 0 is 1 and x prime of 0 is 1. So let's see, when we plug in 0, we get 1 equals, 1 equals C1, right? C2t and the t squared 0 out. E to the 0 is 1, and we're just left with C1 times 1. X prime of 0 is 1. So, we should find x prime of t, right? Got to use the product rule. So derivative of the first is c2 plus 2t times e to the negative 2t plus c1 plus c2 plus t squared times negative 2 e to the negative 2t. And I'll factor out the e to the negative 2t from that as well. And now we can use that initial condition. So we get 1 equals e to the 0 is 1 times c2 plus c1.
I think you lost a t.
Oh, I don't know if I lost a t. I definitely lost a negative, though.
And the derivative of the top should be, I think, c1 plus c2t, right?
Oh, You mean right here?
Yep.
Yep.
Then you carry it out.
Right. Let me fix that first. Catching errors when they happen is good. Alright, so we pulled in that t. Going to distribute the negative 2. So we have minus 2 c1 minus 2 c2t minus 2t squared. That's better. Now when we plug in 0 and get 1, plugging in 0, the e to the negative 2t is still 1. Things that 0 out are that, and that. So c2 minus 2c1. But we know that c1 is 1, so. And that means that C2 is 3. And we have enough to get our, we've got our total solution, which is C1 is 1 and C2 is 3, so 1 plus 3t plus t squared times e to the negative 2t. Questions? Okay. All right. let's do another one. This one will take a bit to do. Here's what I want us to know or observe about this problem. When we look at this, part of what's going to make this one a bit more involved than the last one is that the forcing function has two different kind of types of function involved. We have the exponential term, e to the 0.5t, and then we have the cosine and sine. Now the cosine and sine is still considered like one basic function because the arguments are the same. It's 10t and 10t. If they were different arguments, like 10t and 20t, they'd be considered different families of functions, and it would be even more involved. But here's, we start the same way, always by finding the homogeneous solution. So that means we want the characteristic equation. And what would that be?
R squared plus 2r plus 5 equals 0.
Great. And I don't think this factors, so let's complete the square. So r squared plus 2r equals negative 5. All right, add 1 squared to both sides. We get r plus 1 squared is equal to negative 4. And when we solve, now we have complex solutions. So we have r plus 1 is plus or minus 2j. Or r is negative 1 plus or minus 2j. So we didn't actually identify the last one. This one, because we have complex solutions, this is underdamped. The last one, since we had a repeated root, this was critically damped. And when we have complex solutions, our homogeneous solution, or complex roots, I guess, the real part tells you the power on E, and the complex part tells you about the complement, or the arguments inside your cosine and sine. So this is e to the negative 1t times c1 cosine of 2t plus c2 sine of 2t. So we'll kind of put a pin in this. We're going to have to use it again to come back. But now we can turn our attention to the particular. Now there are two fundamental pieces to this forcing function. They are this piece here and this piece here. I'll call this the A piece and the B piece. We can handle them separately. We're going to find two different particulars. Yeah.
If it was cosine and sine of 10t, would we have to add the t into there?
Yeah, because those would already be a part of the homogeneous solution. Like you mean when we made our
Would it have
yeah.
to be e to the 0.5t as well as cosine of 10t, sine of 10t, or is it only one?
No, because as you'll see, we're only going to handle the we're going to handle the exponential and the trigonometric, the cosine and sine, as two separate problems.
So if either of those were matching, would you have to add a t? Like if it was e to the 0.5t?
Oh, if it was e to the, oh, you mean like matching in this? That's a good question. Because e to the 0.5t, if that were an e to the 0.5t on the outside, that's a good question because it isn't itself a term in the homogeneous. It's just one of the factors. So I think I'm going to have to check and get back to you to let you know for sure. You can usually tell, if I was supposed to put in a factor of t and I didn't, usually we could tell because we start to try to find the constant the coefficient, everything zeroes out. Everything cancels out, and then you're like lost. So usually it could be it's pretty easy to tell if you forgot to include a factor of t when you just try to do out the work. I think the answer is no, that you wouldn't have to, because the e to the 0.5t itself isn't just a term, a standalone term, but I want to check on that before I state it with confidence. So okay, yeah. So we're going to approach both parts of that particular separately. So in part A, I'll call this xp1 of t. And we're just going to handle the e to the 0.5t. I'm going to forget that the cosine and sine parts exist to that forcing function. And if e to the 0.5t were the only part of the forcing function that existed, our basic form here would be just a e to the 0.5t. And then I can find the derivative and the second derivative and figure out what that coefficient is. So take the derivative, we get 0.5a e to the 0.5t. It's kind of nice not having to use a product rule. Second derivative is 0.25a times e to the 0.5t. So now we're going to figure out what a has to be to make this equation true. Now because we're just addressing that e to the 0.5t part of the forcing function, when we set this up, we're going to have our equation x double prime plus 2x prime plus 5x equals, and on the other side, just e to the 0.5t. I'm ignoring the sine and cosine parts. So altogether, we have 5, let's see, that's another one, so 6.25a e to the 0.5t. And this is all equal to e to the 0.5t. So 6.25a has to be equal to 1. And a little division. 1 over 6.25 is 0.16. So this part of the particular is 0.16 e to the 0.5t. Okay, so ready for the next part? Sines and cosines? So xp2. We're going to do the same thing. This time now, we're focusing on this part of the forcing function. So we're pretending that the only part that exists is the cosines and the sines. The arguments are the same, so it's just one piece of the particular. And we're going to have a constant times cosine 10t plus some other constant times sine of 10t. And then we keep going, right? Proceed as we did before. Find the first and second derivatives. So minus 10a sine of 10t plus 10b cosine 10t and for the second derivative, multiplying by 10 again with the chain rule, so minus 100a cosine 10t minus 100b sine 10t. Be careful with your signs. Okay, so now the equation that we're setting up is x double prime plus 2x prime plus 5x equals, and now I'm just paying attention to this part B of that forcing function. So this is equal to 40 cosine 10t minus 190 sine of 10t. So when we make this substitution, it's going to take a bit of work, going to take a bit of doing. So x double prime minus 100a cosine of 10t minus 100b sine of 10t. And then plus 2 times x prime, so that's negative 10a sine 10t plus 10b cosine 10t, and now plus 5 times the original function, a cosine 10t plus b sine 10t. So that's just the left-hand side. We're trying to figure out what a and b are, obviously, and it has to do with the fact that this now big, long expression is equal to the 40 cosine 10t minus 190 sine 10t. This process will be similar to like the first example, the one we did yesterday, in that yesterday what we did was compare coefficients on like terms, like the similar powers of t. For now, this time what we're going to do is just compare sines and cosines. So let me just do a little bit of distributing because I think it might help. Minus 100a cosine 10t minus 100b sine 10t. Okay, so now let's compare the cosines, or let's figure out what is in this line on the bottom, right, the one that I just finished writing down. What should the coefficient on the cosine of 10t be? So I'm going to just, I think, highlight to help out. So there's a cosine, there's a cosine, and there's a cosine. What is the coefficient if we combine those like terms?
I think 95a plus 1b cosine 10t.
Say that one more time.
Sorry, negative 95a plus 20b cosine
Yep.
10t.
Perfect. So minus 95a plus 20b is the coefficient on cosine. So that means that negative 95a plus 20b has to be equal to 40. Because that's the coefficient on cosine in the forcing function. Let's do the same thing now, but with sines.
Negative 95b minus 28.
Yeah. So negative 95b minus 28. I'm going to put the a term first. And so what does that have to equal?
Negative 190.
What does it equal?
Negative 190.
Yep. It's got to be the same as that. Now we have a system of equations. Two equations, two unknowns. My favorite way of solving is usually elimination by addition. So if you multiply the top equation by, I think we can zero out these b's. So if you multiply the top equation by 19 and the bottom equation by 4, that'll get you to the least common multiple of 20 and 95, which is, I think, 380. So minus 1805a plus 380b, and 40 times 19 is 760. And if we, let's see, on the bottom we get negative 80a plus, minus 380b equals negative 760. If we add those together, we get negative 1885a equals 0. So a equals 0. And if a is 0, there's, we could use either of these equations, but if a is 0, then, like looking at the cosines equation, if that zeroes out, then b has to be 2 for that to be true. Okay, I'm going to scroll up just briefly. I'm coming right back down. But we figured out in this XP2 that a is 0 and b is 2. So XP2 is just 2 sine of 10t. And XP1 is 0.16 e to the 0.5t. Great. We're making progress. So that means that our XP particular is just the sum of these two. And now that we have the particular, we already found the homogeneous. So we got our total or complete solution. And that is, let's see, the homogeneous was e to the minus t, and then c1 cosine 2t plus C2 sine 2t plus 0.16 e to the 0.5t plus 2 sine of 10t. What's next?
Find C's.
Say that again?
Find the C's.
Find the C's, yeah. How do we do that?
Use the initial values.
Yeah, good. So they tell us that x of 0 is 0.16. So we can use that first. What? Just wanted to make a little bit more space. So x of 0 is 0.16. So 0.16 equals, when we plug in 0, let's see. When we plug in 0, the sign zeroes out. So we get C1 cosine of 0. Oh, cosine of 0 is 1. So that's pretty nice. So this first part is just C1 plus 0.16. And that's pretty nice. That's 0 is equal to C1. Okay. For C2, or to help us find C2, we'll need the other condition for the first derivative. So let's find x prime of t. Okay, we've got to start out with the product rule. Minus e to the negative t and then the other parts at least don't need the product rule, so that would be 0.08 e to the 0.5 t and then plus 20 cosine 10t. So they told us that x prime of 0 is 40.08. Okay, so when we're plugging in 0, what zeroes out is the sign zeroes out, so that's gone, and then cosine is 1, so we have, when we plug in 0, 2c2 in the beginning. Just that, minus 1, oh, minus C1, rather, plus 0.08 plus 20, We know that C1 is 0. So we get 2C2 plus 20.08 is 40.08. Which means 2C2 is 10. 2C2 is 20. And C2 is 10. Whew. This is a process. It's a good thing it's fun, or it might get tedious. Can you imagine trying to do this if it weren't completely enjoyable? That would be awful. Okay, we got our C's. C1, 0. Let's plug them in. Let's put this one to bed. C1 is 0 and C2 is 20. So if C1 is 0, then that term zeroes out, and this is 20. So we have 20 E. Oh, yeah, thank you. So we have 10 sine of 2t times e to the negative t. Plus 0.16 e to the 0.5t plus 2 sine 10t. How's that? Okay, so look, we don't have class next week. It's a break week. I'm not saying that you should spend your whole break toiling away for the class, but you will have a nicer time if you spend a little bit of time during the break working on assignment 3 versus trying to cram it all in between like Monday and Wednesday, right? So there's I think 7 problems on the assignment, but 2 of them are pretty quick. So I just want to kind of go over and give you a heads up about so the first one is just a homogeneous, not, you're just finding a general solution to a homogeneous, and it takes, that's like the first part of what we do when we solve all these problems. Usually that's the quick part. The second one might seem a little tricky, but it's actually pretty simple. They give you the basis. They're telling you that the homogeneous solution is a constant times e to the 0.5t plus another constant times e to the negative 3.5t. How do you work backwards from that to figure out what the differential equation is? And then we have an initial value problem that's homogeneous. So you are going to find those constants, but you don't have to go through the whole thing about finding the particular. So the first 3 are not too bad. The last 4 are the ones that will take the most effort. I would say really the last 2, because it's non-homogeneous and they're initial value problems. So start. I would just say start on them early, and it gives you time to, if you're stuck, or if you're not sure if you're right, it gives you time to text me a question or send me an email or something, or send me a draft if you want me to look at something. I'm happy to do that too. Again, I want you to enjoy your break, so that's why I gave you something fun to do during, at least to tide you over a little bit. Yeah, so I think that's it. I don't have any other new material I wanted to cover today, and I'm not going to sort of needlessly keep you longer. If you have questions, please reach out. Please do, though, start early on that assignment, and I hope to hear questions from some of you. Maybe during the break, or at least when we have class on Monday, you might come prepared with some questions on those problems.
I wouldn't ever turn that bad. One of my managers at work showed me a picture of my mason jar full of water. It was
Really?
yeah, I'm not ever going back there. So like it never even came out of I was really confused on Sunday when I was going to work. I'm like, why is there air coming out of the faucet? I was like, I think I got all my brain cells this morning, but it's not quite right. Yeah, it was, and I was like, whatever, I'm late to work, I'm ready to go, and then I took a trip to this air and